Okay, Algebra 2. I promised you that we could represent systems of equations as matrices, and here is a look at how we do that. Now, why it works and how we're going to use these matrices will be the subject of future videos, but for now, let's just get familiar with how to represent a system of equations as a matrix. A system of equations as a matrix. So, you notice in this first system, whoops, I just erased it. I have my x coefficients in blue, my y coefficients in red, and the evaluation on the right of the equal sign in green. To convert this into a matrix, all we're doing is transferring the coefficients, just the numbers. We're going to leave the variables where they are because they just gum up the works, right? So we just transfer in exactly the order they appear left to right. Here's the coefficient on my x in my equation number 1, coefficient of the y in equation number 1, and there's what it's all equal to. Likewise, we did the same thing for equation number 2, just x, y, and equals 2. This replaces the equal sign. So this line, or this vertical bar, replaces the equal sign from the equation. So we lose the variables, we just write the coefficients in the order that they occur. We have an equal to bar, and then whatever number it's equal to on the right. So let's try it with this system of equations, the second system of equations. I'm going to rewrite the coefficients from equation number 1, 2, 1, have an equal bar, and 9. I'm going to rewrite the numbers from equation number 2 as 1, negative 6, negative 1. Now notice in both of these systems, everything is in the same order. X, y, and my equal to all occur in the same order. Left to right, everything is in the same order in both systems. Also notice that I wrote the coefficients 1 in front of the x's and 1 in front of the y's in each system, and we know that that's not normally how we see equations, right? If there's no coefficient written, it is understood that the coefficient is 1. So don't let that trip you up. Let's look at a system where everything isn't in the same order. We have to put all of the variables and everything, the equal sign and all of that in the same order, left to right, or the matrices will not help us solve the system. And again, we'll see why that is later. But for right now, we just need to practice. I don't know if you can hear the middle schoolers out in the hallway, but oh my goodness. Okay, equation 1, equation 2, equation 3. I'm going to leave equation 1 exactly as it is. I'm going to rewrite equation 2 slightly because notice there is no y variable in equation 2. And I need to note that somehow. So x plus 0y plus 3z equals 12. For equation 3, I need to do a little bit more work because I need it in x plus y plus z equals something, and that's all kind of messed up. So let us rewrite equation 3 in the proper order. Let's say negative 5x plus 1 equals y. I want x and y on the same side of the equation, so I'm going to subtract y from both sides. I want 1 on the right side of the equation, so I'm going to subtract 1 from both sides, and I get negative 5x minus y equals negative 1. Using this now, I'm going to transfer my coefficients. I'm going to transfer all the numbers and leave the variables behind. I have a -5 as a coefficient on, I'm going to rewrite this, hang on. I'm going to rewrite, I'm sorry, my equation number 3 to show that there is 0 z. I don't have a z. So when I rewrite this, when I set up this matrix, I'm going to transfer all of the coefficients from equation 1, all of the numbers, leaving the variables behind, and I get 1, I have a 1x, I have a 1x, I have a -3, I'm working on equation 1 right now, I have a -3, and I have a +1, on the other side of my bar I have a 6. That bar means equal to, right? In equation number 2 now, I have a 1 on the x, I have 0 for y, and I have 3 for z, 12 on the other side of the equal sign. Equation number 3, I have a -5, I have a -1, and I have a 0 and a -1. And I put that inside my brackets, and I am finished. So I would like you to practice. I want you to rewrite the following systems as matrices. Notice the first one is in the proper order. We have x, y, and a number. X, y, and a number that it's all equal to, right? Here we have x, y, z. We have y, z, right? X, y, z, and a number. That looks good. But down here in equation number 2, we have y, z, no x. Then in equation number 3, we have x on one side, y on the other, and none of that is going to help us. They all have to occur in the same order. So you have two kinds of matrices that you have to write. One that is already straightforward, you just have to transfer the numbers, and the other one, this one, where you have to do a little bit of work before you can transfer the numbers into the matrix.